There we go. I think so. My suggestion would be so we have two options. We can go through a bunch of questions that were asked in advance, but I think it's a lot more fun since we have a 3.5 barrel here. We have the new 1 barrel here. There we go. We have Chef as well. Hello, Chef.
Hi, Jeff.
We could just go through whatever things you want to see or hear about before we go through the Q&A. So if anyone wants to see something, wants to know something, wants to go to something, wants us to show, demonstrate, talk about something, put it in the chat. I'm happy to walk you guys through it. It's a bit more, it's a bit simpler and quicker, I think, than just to go through the Q&A. Perhaps as a bit of background, me and Mendel will introduce ourselves, and then you can ask all the questions you want. Mendel, you go first.
Yeah, I think it's also a good idea indeed to have a walkthrough on the systems, like Cornel said. And then if anybody has questions, yeah, you can ask them by chat, or you can unmute and ask them. And after that, we can go to the Q&A questions. And also, Michael Fabian, the CEO of SS Brewtech, will pick in at 4 o'clock. So yeah, I don't think we have to wait more minutes for other persons to come. So Cornel, I think it's best if we start with the 3.5 BBL system.
Yeah, let's before we do that, if you can introduce yourself, and I'll introduce myself.
No problem. Yeah. So my name is Mendel van Dalen. I work for 5 years now at Brouwland, and together with my colleague Jeff Koetele, who is also here in the Q&A session, we are selling the SS Brewtech Pro equipment, the 3.5 BBL brew houses, the 1 BBL brew houses, the tanks, even the bigger brew houses, the 5 and the 7 BBL brew houses. And we wanted to do this Q&A session to give you guys more information, and that you can guys also ask some questions specific for the brew houses. So yeah, that's quite it. Maybe it's a good thing to introduce yourself now, Cornel.
There we go. I was looking for the remote for the air conditioning, but can't find it. So I'm Cornel Bullens. I'm been working with the SS Brewtech equipment for a very long time now, and I own this brewery. So we have a 3.5 barrel brew house here. We have the new 1 barrel brew house. I used to have the old 1 barrel brew house as well. I worked a lot with Brouwland as a Brewtech directly to learn about brewing them and to fix all the mistakes that I made on the brew houses to make sure that I could actually get decent beer out of it. And by now, I'm happy to say that I think I understand the brew houses quite well. I usually rent out the brew house, but every now and then I still brew myself. So my suggestion would be for our participants here, if you want to see something, want to go through something, if you want us to talk about something, now's the chance to ask. We can go through some of the Q&A questions that we got as well. But I think it's a lot more fun if you have something, you want to see something, that we'll just go through it. Lots of people are typing. Exciting.
Yeah, I think Jaap has the 3.5 system, so maybe he can ask some things he want to know.
Yeah. Okay. Can you show the underflush on the 3.5? I'm not completely sure what you mean with that.
It's easy about my microphone. You got the underflush underneath the filter bed. You got three three connections where you can flush away all the small particles which has come under the filter bed.
Do you mean the rescue inlet or?
No, if you go to the filter, the Lauterton, and you take away the filter,
Yeah.
you'll see three dots.
We'll take out.
And on the bottom you will see three dots now.
Yeah.
Okay, that's the underflush. They are made to wash away all particles which came through the filter.
Oh, you mean the lower sip?
Yes.
There we go, lower sip. So
Yeah,
Okay,
the
you call it
nozzles of the
lower
lower
sip.
sip.
Okay, we call it underflush. Sorry.
yeah, no, that's fair enough. No, the only reason I call it lower sip is because the handle tells me it's a lower sip.
Okay.
As simple as that. So, sure, we can take a look.
If you don't have water into it, I thought there was some water or something into it, but don't bother then. Okay.
So to be honest, I'll be very honest with you. I never use it. I never use the lower sip. So whenever you can see my plate here. It's clean. So usually when we're done and when we're getting ready to sip, so I actually made a change to the brew house, but it's quite simple for you to do this yourself as well. To take the outlet from the hot water from the plate chiller and then route it back into the mash tun. It's essentially what I did, but then with hard piping. So whenever we are doing the knockout and cooling down the wort, I collect the hot water in the mash tun. I use that to flush the system to make sure everything's clean, everything's gone, everything is nice and tidy. And then when there's about 100 liters left, I add caustic to it, and then I just start the rinsing, start to sip with the hot water. It saves about 30 to 40 kilowatt hours. It's quite substantial, the money saved for that. And afterwards, when the caustic is out and everything is flushed down with clean water, we take out the filter plates and we wash them down. For me, that's been the easiest to clean filter plates and keep them clean. I've never used the lower sip, to be honest.
Okay.
So I did it. Happy to show you, but I haven't used it.
No, that's okay. No problem.
Where do you use
If you guys want, we can also share some pictures of the modification with the hard piping that Cornel did on his brew house, because it's not easy to show it now in the session live. But if you want, we can also share some pictures of that.
Back and then, yeah, you had two questions. Let me make sure I understand the questions. Where do you use the connection for one on the right side next to the two connections from the manifold? You have to direct me which connection you mean, and then I'll happy to show you that. Maybe you can, if possible, come off mute, or else we can have it. Well, on the right here, I have my. This is my hot water in, coming in from the HLT. So I have there's a 400 liters HLT that's supplying direct hot water to the valve tree over here. So I can do my sparging with 80 degrees water, but it also goes to the rescue underlet. So should I need it, I can push back I can push up the grain bed if it's stuck with hot water instead of cold. And the other one is just the cold water coming in to the mixing valve as well. I hope that answers the questions. If that's the last question, then we had step mashing tips and tricks. Yeah, you came off mute. If you want to elaborate on the question, happy to go into it.
Do you hear me?
Yep.
Yeah, next to the manifold, there's like cold and hot water inlet.
Yes.
And on the back, there's a third connection with a tri-clamp on the bottom, right?
Oh, yes.
That one.
Yes. And there's a solenoid connected to it, isn't there?
Yeah.
Yeah, that's a mistake.
Yeah,
so,
that's you can see it as a spare solenoid because
yes.
when there's another solenoid on your system that's broken, in some time you can dismantle it and replace it by that.
So here's
solenoid
mine. You don't need it.
Thanks.
So what happened? So I asked SS Brewtech this, and apparently someone misread the diagram and put an extra there. So it's a free spare for you. But what the actual outlet is it's not an outlet, it's an inlet, and you can use it for. So some breweries have an external sip card, right? So it's a sip card, has a heating element, caustic, acid in it. And what you can do, you can actually connect the SIP card to that connection. And at that point, you can push external cleaning fluid into the system. It's connected directly to the lower SIP arm as well. And you can use it to push cleaning liquid into the system. That's what it's for.
Yeah, cool. Okay, then I know how to maybe use it in the future. And the question with the step meshing is, like we had a brew day yesterday. And we had a one-step mash at 66 degrees. There is no problem, but in the mash, the first couple of times, and the overheating protection kicks in a lot of times. And Jeff already gave some tips and tricks, but maybe you can explain it a little bit more about how to use the pump and the valves, I think.
Sure. So let me caveat some of my statements before. So. Before I'm going to sound like a smartass, I have burned so many meshes, it's not even funny anymore. So believe me, I've I've thrown away a lot of very good brews because I was just doing it the way I was taught to do, which was apparently wrong. May I ask you, what are your mesh steps, right? So you've got hot water in your mesh tun, I suppose. So if you're meshing in, how does your mesh look like? What are the steps you take?
Yeah, like for instance, like the last couple of things we brewed was a typical Weizen. So we had the multiple steps. We started around, I think 45 degrees, and then heating up to mid 50, 63. So a lot of temperature going up, but we started.
But before that, but before that, so the mesh tun is empty. What do you do?
I fill it up with approximately 300, like say, 80 gallons of water from the water inlet, with around water temperature around 50 degrees.
Okay. And then you add the mesh. The malt.
Like I want to start at 45, so I put in water that's around 50 degrees temperature, and I start meshing around with 50 degrees, so it can set back to 45, and I put in the mush and start stirring.
So the water is 54 degrees, right? And then you start adding the melt. And do you stir or do you?
Yeah, I do a lot of stirring. And then I connect I think, what is it, the center, the manifold center or something?
Yeah.
What's it called?
Yeah, the mesh manifold is this. It's this thing.
Yeah.
The thing.
Yeah.
So how long do you wait between stirring and filtering?
Filtering?
Well, as soon as you start running it through the manifold, you're meshing or filtering manifold.
Okay. Probably at the same time. So sometimes pumping it through the manifold and stirring.
Yeah. So that's going to be a problem.
Okay.
You can't do that.
Okay.
That's and don't worry, we all did it. That's how we messed up a lot of beers. So what you would usually do, so there are a couple of steps with the 3.5, and they're the same for the 1 barrel, to be honest. So when I start my brew day, I fill up the tun with about 350 liters of water.
Yeah.
I heat it up, and I just use the mesh tun elements, and I heat it up to about 3 or 4 degrees over the temperature I need. So if I want to mesh at 54 degrees, I would set my temperature, and I usually run it on my wort temp. So I don't use the mesh temp, I use the wort temp, and I would set it to 59, right? 5 degrees higher, 4 to 5 degrees higher than what I need. As soon as my water is warm, throw in all the malts and stir like crazy. Just make sure everything is stirred in correctly, that there are no dough balls anymore, and it's a nice even mesh. I also add in just a shitload of rice hulls. So you cannot add too much rice hulls. Just make sure you add like a decent amount of them. I think in weight, they say about 2 to 3%. I buy them in like these big bags. I always throw in at least a third of a bag. Just throw in as many as you want. You can't add too much, and it will dramatically help with filtering. Keep stirring and make sure it's a nice even mesh. And once a nice even mesh, the first thing you do is don't touch anything anymore. Just stop it. Wait for 15 minutes. After you've waited 15 minutes, connect the mesh manifold. So I'm pointing to it, you can't see it. I'll take my mesh manifold. I'll connect it to my Volant connection. I'll set my pump to 25 degrees, 25% should be correct. And I usually recirculate at 25%. If you don't wait 15 minutes, you're not giving your mesh a mesh rest or time to settle, and you will not have good filtration. To do the temperature steps, you need to have that constant filtration, that constant flow. So after meshing in and stirring, wait for 15 minutes, then start your actual meshing, and you will see that temperature steps will become super easy for you. The reason that it's kicking off, that it's stopping with the heating, is that there's a sensor at this level, just below the plates. So as soon as you essentially suck away all the wort and the heating elements are dry, it stops heating the heating elements. So by not giving the mesh time to rest, you're creating a stuck mesh. And you're making it very hard for yourself. That makes sense? Hope it makes sense.
Okay, that's a good explanation. Maybe we can also add that it's a rim system. So steering is good in the beginning when you're meshing in, but when you're using the manifold, just let it flow through and search for a nice flow. Like Cornel said, 25% on the pump, and then you will not have problems. So,
yeah, so any stirring you do after meshing starts means that you have a problem. It's as simple as that. No more stirring. Once the mesh starts, it's you need to make sure that the flow is there. So what I usually do, especially with beers that I'm not so certain of, with beers that have a lot of wheat or have a lot of oats, I every 5 minutes, I just pick up the mesh manifold and I look at it. Do I still have flow? Do I still have flow? Because as soon as that flow stops, that your day is not getting any better. So because we also have people with a 1 barrel in here, essentially the same thing. Once you mesh in, and I'll walk through the 1 barrel. Once you mesh in, just stir like crazy, give it a 15-minute rest, then slowly start your recirculation. If you're not getting a decent flow, and with the 1 barrel, you start your pump and you use your valves to control the flow. once that flow goes, it needs to be a decent flow. Only when you're sure there's a decent flow, add the heat. Then you're good. For the 1 barrels, whether it's new or old, get one of those pure flow valves and replace the Voorlout upper sip valve here with one of the pure flow valves. These are way easier to regulate. These are like the butterfly valves. They go 0, 80%, 100. There's no real fine tuning with these ones, and you can look inside. You can see it in the light. If I start applying pressure, you can really nicely fine tune these. So these are like 40, $50, and they're well worth the money. They make your life a lot easier.
That's indeed a good upgrade. Another question from Jaap. You let the manifold rest on the mesh bed or on top of the above the liquids. Let it rest on the mesh bed.
Yeah.
And that's also part of the explanation that you need to let the mesh rest for like 15 minutes. Because otherwise, if you place it on top of the mesh bed, there is no mesh bed because everything is liquid, and so you can, if it has a rest for 15 or 20 minutes, you can just put the manifold on the grain bed. And also, if you want to see if there's still a nice flow, just pick it up a little bit, and you will see through the holes that there's still a flow or not. And you can control it. If you take the silicone hose, it's not that hot, so you can just control it every 10 minutes or 15 minutes if the flow is still going good.
So one of the things I recently saw and I thought was pretty smart is someone took the sparge ring and they connected it to the water inlet, so right here, and then they put the mesh manifold on top of it. So they put it on top like this, so they could see actually the flow. And for the first few brews, to get a way better indication of how the flow was going, if it made sense for them, if it was still going through, if the flow was okay, and it made it a lot easier to see if the flow was still going. Because to be honest, in the beginning, when the wort is still clearing up, I can see it in the side glass. Once it becomes clearer and clearer, that thing doesn't mean anything to me anymore. That's also we did.
But also, if you start with it with the manifold, you will see a little bit of wort rising up. But if you have a good flow, it will also always stay on the same level. Then you know you have a good flow. If it rises very fast, yeah, you know there's something wrong with a bad filtration during the mesh. And yeah, you need to have more rise holes or something else.
And so we had a question from Bartels around the detailed mesh steps. Well, so to be honest, both on the 1 barrel, because I just did a couple of brews on the 1 barrel or on the 3.5 barrel. As far as the detailed mesh steps, for me, the things that have worked really well is before you mesh in, like put the malts in, make sure the water that's in the tank is a couple of degrees hotter, like 4 to 5 degrees hotter than you need, because you're gonna lose 4 to 5 degrees when putting in the grains. Put in just a crap load of rice hulls, as many as you can. You never have too many rice hulls. I just can't emphasize that enough. It makes your life so much easier. And they cost next to nothing. So just throw them in as many as you can, makes your life better, and then let it rest. 15, 20 minutes, at least 15 minutes. Let the mesh rest before you start filtration, or else you're gonna get a stuck mesh, and keep a good eye on it. And once you've done that 5, 10, 15 times, you get a good feeling for it. And so I know that, like most of the brewers that now brew on my systems, they really had to get used to so I need to make sure the filtration is okay. How does it work? And then when they got used to adding the rice to it and then giving it some rest, they don't even look at the circulation anymore. They know it's going to be okay, and they know it works well, and it just works well every time. So that's really give it enough mash rest, and then you should be fine. As
Maybe
far as
that's-
the deep,
Maybe that's also a good thing to say. Corneel lets other people brew on his 3.5 BBL brewhouse and 1 BBL brewhouse. So there are many different people brewing on it for the first time, second time. So yeah, and he explains it to them, and I think for now he didn't have a lot of problems with it. So.
No, so I'll happily take the PC and show you the elements. The elements are nice and clean. I have no burnt elements, and I think we've used it now for about a year. And it's a production brewery, so we have 9 tanks. So every 3 weeks we fill about 9 tanks here. So it's 2 to 3 brews weekly, and just works. The biggest things that we did notice was that if we don't explain like the big stuff with meshing, like stir like crazy, wait for 15 minutes, then start filtration, people are going to get stuck meshes. If your settings on your grain mill are too fine, you're going to get stuck, right? That's a little bit. So I'll tell you a story. I actually accidentally dropped my grain mill. There's an upstairs here too, and I had the grain mill upstairs, and I dropped it all the way down. So I had to have it repaired, and the gap was changed. And then people were so used to the grain mill being a specific setting, nobody checked it anymore. Turned out it was set a little bit finer than before, and we immediately got stuck meshes again. We immediately had just not enough holes to get a proper filtration, and were stuck. So that was one of the things that we noticed, that, hey, we need to make sure that we have a proper filter bed. We need to have a proper setting for our malt mill, have enough rice hull, and have some patience with it. Same with the boil kettle, by the way. This is also the same for the 1 barrel as for the 3.5. You might notice here that there's a weird thing here. It's a filter that we build in. I had it built in because I have people that brew here and that they might be stubborn. On the 1 barrel, there isn't one, and I haven't had any issues with the plate chiller yet, because after we're done with the boil, we do a 20-minute whirlpool, of which we do 15 minutes of full speed whirling, and then 15 minutes of rest. So 5 minutes, 100% whirlpool, 15 minutes rest. We open up the knockout, we open up the boil kettle pump, and then we dump like the first 5 to 10 liters. And in the side glass, you'll see all kinds of junk coming out, and then you'll see clear warts. We close the dump, start pumping, and then we stop.
It's very important to use a dump valve. The guys from SS Brewtech also told me you have to use the dump valve because you will have all the proteins and the hops coming out. And if you're not doing it, it goes straight into the plate heat exchanger. So yeah, it's definitely very important.
Yeah, we had a lot of. So I had a lot of complaints about that the plate chiller was stuck every single time. And I added the filter in there because I got it stuck every single time. And I did complain to SS Brewtech about that. And I got back an email that asked me if I actually used the dump valve. And I said, I don't. And they told me exactly this, right after the whirlpool, dump the first few liters, then start your knockout. And no problems ever since. So that's been very helpful. It does bring us to the little thing that we can yell at Mendel for, because the stuff that I'm telling you right now is stuff that is actually in videos as well. I know some people are asking us about, we saw some of the Q&A like, hey, there's a brew house, but there's no real information on it. So Mendel and I, being the movie stars that we are, we made a very good video on like all the tips and tricks for the 3.5 barrel on how to do a brew day. They are essentially this. You would use the exact same steps on the 3-vessel 1 barrel or on the 2-vessel 1 barrel. The only difference is that with the new 1 barrel and with the 3.5 barrel, you have an external HLT. With the old 1 barrel, you have an internal HLT. That's really the only difference. The rest really is the same. With there's a calandria, there's a mash tun, there's a heating element that you need to make sure that is submerged, or else you'll burn them away. It's all the same. So these videos will be available once they're edited and released. I'm sure Mendel will tell us when they're ready, right?
We're working on it. Yeah, the guy from marketing, he still needs to edit the videos, and then yeah, we have to make a nice video. But yeah, I'm sure we will, because I went 2 days to Cornel's brewery, and like you said, we are film stars, so we made a nice video with the whole brewing process, some close-ups, some tips and tricks. So yeah, if it's ready, we will put it just online, and everybody can see it and share it. So I think it will be nice. Also, maybe for Bram, we are filming also this Q&A session. So if anybody wants it, we can share it afterwards, and we will also share some pictures of the modification Cornel did for the hot water, and other things. If you want some pictures of anything else, of the filter, because we are also selling those filters. If you say I want to use a dump valve, but I have people that are also brewing on my brew house, and I want to be sure, we are also selling those filters with a 1.5-inch tri-clamp in and outlet. So yeah, just send us an email, and yeah, we can make a quote.
So one of the things that we actually recently started doing, and so if we are doing very hoppy beers like Nijphuis, we actually bought an additional one, and I got it right here. Let me quickly take it out, because I was actually running acid through it last night to clean it again. I can just take it out. Yep. So I like these filters, and there we go. So these are the filters. Make sure I don't hit myself with acid. These are the filters. They come in a 50 and 100 micron type. We are using the 100 micron. And when we're filling up IPAs or Nijphuis, we are now directly attaching these to the fill port on the unitanks, and we're filling through these to make sure we don't get any hops in either the bottles or the kegs, and it made our life a lot easier. Actually, I had one from I had that whole kit somewhere here from is this one from Brewtools, but it's all plastic, and is this one. And after the 50, I think I've broken 6 or 7 of these. So the stainless steel one from Brouwland is a lot cheaper, to be honest. So we went with that one in the end. It was just a random thought. Let's see. Any questions? Any other questions from you guys? We're here now. We can walk through everything. I'll show you something different in the meantime. For the people in Europe, which is all of us. So if you look at this ring, this is a different ring, right? This is a tri-clamp seal. If you look at it from the side, you can see that there's a little lip to it. So if you buy an official one, and I only recently learned this, if you buy an official one from Monkaton, for example, they cost next to nothing, like 30, 40 cents. You get an EPDM, which is a lot nicer than the silicone ones. But the lip that's on there is actually Euro spec, is DIN spec. They are actually supposed to have the lip. The exception to is that Americans don't use the lip. So when you bought the SS Brewtech stuff, you didn't get ones with the lip. The main advantage of having the lip, and let me get a little piece here, is that if I have something that I want to connect it to, and I'm using one hand. If I do it like this, it falls off. But if I take the lip side, it stays connected. So these things are like super awesome. So I would definitely recommend if you're looking for the if you're looking to buy some new seals for the tri-clamps, get the official DIN spec with the lip. Because if you're putting things on like a hose or the mesh manifold, not having to wiggle with the little silicone seal, it makes your life a little easier. Random thought. Oh, we have a new guest. Welcome, Michael. There we go. It's not the new Michael.
Yeah, welcome, Michael.
Hi,
He
hi.
also has a 3.5 BBL system, I guess.
Yeah, I do.
Yeah. Okay. For Michael, we will record the whole session, so it doesn't matter if you didn't saw the first part, because we will record it, if that's okay with you.
Okay, cool. I was about to ask actually about that.
Okay.
Thanks.
Yeah.
So we've already gone through a bunch of questions. Are any questions from you, Michael? So we have about 20 more minutes before we can start yelling at Michael from SS Brewtech. Before that, any more questions? Anything, things you want to see, want to talk about? We can look at everything. We can address everything.
I don't know what you have discussed already. So
It's fine. You can ask whatever you want.
yeah, I have actually the problem is sometimes when I'm meshing it overshoots the temperature quite a lot.
Mm-hmm.
Even though the flow is okay. How can I?
You're using the 3.5 barrel, right?
I'm sorry.
You're using the 3.5 barrel, right? This one.
Yes.
Yes,
Exactly.
yes, he's using the 3.5 BBL system. Yeah.
When you're doing the so there's an option for the mesh stand. There's an option for you to either select wort or mesh temperature when you're using the heating element. Which one are you using?
Wort.
And the overshoot. Where do you see the overshoot? Do you see the overshoot in the wort or the mesh temp?
Wort.
And how big is the overshoot?
Sometimes it's not okay. 4 degrees. Sometimes, and it depends if the flow is very slow. It can
Yeah.
You have to be very careful about it. But this also happens if the flow is good.
And silly question, when you mesh in and you add the malts and you stir a lot, how long do you wait before you start meshing, like starting the pump?
At least like 5-10 minutes.
Make it 15 at least.
Okay.
So,
but then during meshing, I still have to stir it a couple of times.
Yeah, that's bad.
Sometimes when it gets stuck, you have to stir it.
Yes. So so two things about that, because I carefully avoided stuck meshes because I hate stuck meshes. So everybody gets a stuck mesh, right? So let's address two things. So the first thing is that we addressed that before. Once you start filtering, because we're brewing American style, so we're constantly filtering. You don't. So you only stir when you're meshing in. All right, so you have your water, put in the malts, stir a lot, then don't stir again. If you have to stir again, there's something wrong. Make sure you add a crap load of rice hulses and make sure everything is nice and homogeneous before you start filtering. Wait for 15 minutes at least, then start the filtration process. So what happens if you get a stuck mesh? Because your temperature shoots. So, well, let's split it in two. First, the temperature shoots. They happen when you're adding hot water on top of it, essentially to heat up everything. It goes through the elements heat it up, they throw it back in the kettle, and then that's the way it heats up, right? But if your heated up water goes through it very slowly or doesn't touch a portion of the mesh because it's stuck over there, it needs to keep heating it up to make sure everything heats up and you get overshoots. So probably most likely that is a sign of a stuck mesh. And I would say 2-3 degrees overshoot during heat up. Yeah, that can happen. But if it's more, it's probably a stuck mesh. If you get a stuck mesh, the thing that I usually do is I open up the hot water. I usually use my rescue underlet to pump hot water about 50 liters back in the mesh tun, so that the filter bed rises. You have to make sure that when you use it, you close your pump inlet. You don't want to push that water back in the pump. You want to make sure it's pushing against the grain, pushing it up. So I do that, 40, 50 liters. I take out my mesh manifold, I hang it over here. I stir a lot. I wait for 15 minutes for everything to settle again, and I restart my meshing. And I've had very good results getting meshes unstuck, because everybody gets a stuck mesh. It happens every now and then. That's one of the ways that's helped me. If it gets stuck, like during my mesh out or during my sparge, I usually take my my pedal. So I have this nice stainless steel pedal, and instead of stirring, I just take it and I just cut the grains so that I might not get all the sugars, but at least I have some flow again. Those are the two things that I usually do to get that done. In my opinion, in my experience, most of the stuck meshes were because there wasn't enough time to let the grains settle and build a decent filter bed. I hope it helps you a little bit, Michael.
Yeah. It does. Well, yeah, the overshoot problem actually sometimes for example, when I need to heat water, just water, you know, and so I how I do it, I recirculate and I'm checking the water temperature actually, and it overshoots as well. So there is no stuck meshing because there is no grain. So the flow is perfect. And okay, what pump speed should I use for meshing, for example, or you know, when I do this, because you know, if the speed is too low, maybe it can overshoot. But I usually do this like 25%, from 25 up to 35%, something like that.
I do the same. But let's test it. What my kid does, right? Because we have something here. We can just test it. We'll just see what happens. Let me add some water and we'll heat it in the background. So I'll go for some water, and then I'll go for let's say 40 degrees. And then we'll let it run in the background, and then we'll see what happens. As far as a mesh, I always run the mesh between 25 and 35%. I've always found that to be sufficient. So what you're doing the right things as far as I can hear. And if you really get this overshoot, the thing that I would think is best is to log a ticket as a Brewtech.
Yeah, normally I don't have problem with stuck meshing.
Yeah,
I just
yeah.
It can also be a sensor problem. It can be, but yeah, we can also replace it if the problem stays. We can also ask SS Brewtech for a new sensor. So that's not a problem. Because when it also. Mm-hmm.
Yeah, I will. I took some videos, so I can send it to you as well.
Yeah, that's very interesting for us and for us as Brewtech. So we can take a look at it. But if it's necessary to send a new sensor, it's not a problem to do that. Okay. Because it's strange that you're also having it when you're just pumping water. So, yeah. If it's necessary, we can replace it.
I thought it can also be because it's let's say it's only 50 liters, for example, because that's the minimum is, I don't know, 40 liters or something. So when there is only 50 liters, you know, the elements are too strong for 50 liters. So it might be also this. I never tried with water like 400 liters or something.
Okay, so maybe it's also best if you try it before before starting the mesh. You can try it when you're heating up your mesh water. You can try it. Because with water the overshoot is also like 4 or 5 degrees, or it was less with water.
No, it was like with less water, like 50 liters. It's basically the same, but not all the time, actually.
Okay, yeah, 50 liters, that's not a lot of water, indeed. So.
Yeah. I'll do some tests as well. So
yeah, okay. And if you have some videos, please send us.
Okay.
And we will try to solve it for you. Yeah, no problem.
So I do have 2 points. So Michael, how old is your brew house?
Sorry, say again.
How old is the brew house? When did you purchase it?
It's slightly more than a year. I think 1.5 years, something like that. I think I got it last January, like the year before.
Yeah.
Or the one before.
So I know that there was an update for the Meshton software that was given to some people that had issues with the elements. So it would be better in heating up with a certain percentage, just like you have with the boil kettle. So maybe that could help. But in the meantime, we're doing a test in the background. There's 150 liters in the mesh tun. I'm recirculating at 30%. And I've set it to go to 40 degrees based on the wort temperature. So we'll see what happens.
Okay.
Yeah, so if that overshoots to 50, then we all have the problem. As simple as that. So any other questions, any other things that we want to see?
Yes, step meshing, how to do it efficiently. I mean, like quick enough. Is it possible?
Yes, we talked about that already a little bit. It all boils down to the only way to do a good, efficient step meshing is to make sure that your initial filter bed is good. It's really what it boils down to. In the big system, in the 3.5 barrel, I do about 1 degree every 2 minutes. So if I'm in 66 degrees and I'm doing my meshing, and when I do my mesh out and I go to 78 degrees, it takes me about 25 minutes. And then I'm at a steady 78.
I think it's about the same what I can achieve.
Yeah.
You know, they say that it should be like 1 degree per minute. So
well, it depends on the amount of water, right?
Yeah.
but it's roughly 1 degree a minute, 1 degree every minute and a half. Yeah, I think going up 12 degrees, 20 minutes. 20 minutes is about what it would take for me.
Okay, so
and
I do everything correct. Actually.
Yeah, no, I don't hear anything wrong. So
maybe I thought maybe there is a trick which I didn't find. So there is no other trick. Yeah.
No, it sounds good. The one thing that I'm just thinking, as far as like a brew day, if you're talking about times, you should be able to do a full brew day, including a step match with let's say 50 to 60 to 78. You should be able to do that in about 7 hours, including sip. That should be a normal brew day on any.
That's a normal brew day.
I just finished an hour ago.
Yeah, so that's and then you started this morning between 7 and 8, I think.
Yeah, meshing in 7 o'clock. Yeah.
Yeah, and that's fair, right? That's what I would say is a normal time frame.
Okay. Yeah.
So the one trick that we haven't talked about, the one trick that I can highly recommend. I've got Michael. I'm going to show. Sorry, Michael. I'll let you introduce yourself. I'll show them something naughty. So one of the things that I did is I added this piece in the calandria, because if you do that, it still fits, and now you can boil about 530 liters of wort. It makes your brew day a lot more fun. Now you have a 500 liters brewery. You just went to a 4.5 barrel. You see, free upgrade, Michael. Free upgrade.
Yeah, there you go. Just increase the volume.
Hi, Michael.
Still a 3.5.
I'll let you introduce yourself.
Hi, everyone. My name is Michael Fabian. I'm the president of SS Brewtech. And, we've been working with Brouwland now for about the last, 5-6 years? And Cornel and I have probably been talking for the better part of 10 years. So we all go way back. And, thanks for taking your time today to, sort of learn a little bit more about our systems and, how we design them and, sort of how do they perform in real world applications within your brewery. If there's any questions I can take, or, I saw I'm just kind of jumping in. It's an early morning for us over here, but, if anybody wants to bring me up to speed on kind of what the discussion topics are, or what, I can jump in and help with, let me know.
I think, Michael, there's one question. We have Bram on the call. I think he's going to ask the question, certainly. And we have other people that will have the same issue. Bram, is there something that you would like to learn about your 1 barrel brewing installation?
I'm sorry. Say it again, Cornel. My internet connection maybe broke up there. I sort of missed the end there.
Might be me. So one of the hot questions that is coming up is that a lot of people with the 1 barrel, they are still experiencing issues with the heating element in the rims. I know we talked about this before, but it's a recurring issue, and it's wondering what your thoughts on that.
And that's something, we have talked about, quite a bit before. So sort of starting at the top, the way the system was designed with the rim system, the total heating element wattage output of the system at any one time, the way we designed it in the United States was about 11,500 watts. And, when you take that 11,500, you break that out, you end up with about 4,000 for the rims and 7,500 for the HLT. Preventing scorching or issues with your rims element, all comes down to keeping a sufficient amount of flow through the system at all times when the rim system is active. there is not, an SSVR or a voltage modulation feature on the 3-vessel 1-barrel system. That's something we actually added to the 2-vessel system. And it provides you a little bit more control. But keeping that flow to prevent scorching is going to be your sort of your number one thing that you want to monitor during your mash process. Secondarily, we get a lot of questions about cleaning the element and servicing the element. And Cornelia and I were talking about this yesterday. We really recommend with all electric brewing systems, it's a good practice to have, but running through a acid wash during your cleaning cycle. I know that, most people when they, come from or have experience with a steam brew house or something along those lines, they're not used to running an acid wash in their brew house, mainly because it just doesn't require it. It's caustic only. With an oxidizer, remove those heavy proteins and it's sort of job done and move on. But, having that acid rinse is pretty key, because what we found is, that calcium buildup on the element can act as an insulator. And that can cause you problems down the road if it's not addressed. So, with an element that's not visible, like the rims tube is not visible, and it's something that, with the boil, kettle element or the HLT element, well, yeah, you can easily identify problems. But since the rims element is not visible, that's why we always recommend doing acid treatment on it. It removes those heavy calcium deposits that form on there, act as an insulator, and then is a precursor to causing scorching. So, whenever you get that calcium buildup, that buildup of heat under that calcium will lead to scorching if it's not serviced correctly. So most important thing is having a clean surface on your element so that element can efficiently transfer heat from the stainless tubes on there to your wort directly.
And that it's smoother also. If the surface of the heating element is smoother, there can scorching. Yeah.
Yeah, 100% agree. So, if you have very hard water, be mindful, because you should be basically removing and servicing that element, giving it a quick brush every few brews. If you have relatively soft water or you're using treated water, RO water, you don't need to be as on top of this, because there's just not as much, bicarbonates or calcium in your water to attach to that element in the first place. So, those are just sort of a few maintenance, recommendations on preventing scorching from happening. But then also, your biggest factor is going to be moving wort through there as efficiently as possible. And, whether that's, on a brew that you have a lot of protein content, so you might want to consider using rice hulls and things like that. I know some brewers are not as big a fan of using rice hulls. I'm probably one of them myself, but if you do have a heavier protein content, using some rice hulls can drastically improve the quality of your beer on a 3-vessel system.
Oh, we have new people.
Welcome, Stan.
There you go. So, Stijn, welcome as well.
Thank you.
So we have Michael on the call as well. Maybe if you want to quickly introduce yourself as well, you can ask Michael any question you want.
Yeah, thank you. My name is Stijn. I'm the brewer from Brewskebor, also with the SS Brewtech, of course. Had a bit of a troubles with burning some mesh tun elements.
Mm-hmm.
So yeah, it's quite an issue over here. So yeah.
So something I want to address, with the mash tun, basically all the heating elements as well. The original system was designed for, that 380 volt to 400 volt power, harmonized 3-phase. So if you're seeing, or, if you've uncovered any higher voltage irregulation, that's something to be concerned about, because with 3-phase power, even if the voltage is, for example, 10 or 20% higher, it's an exponential amount of heat that is run through that resistive element. It's exponential. So It's not just 10% more heat. It's actually more like 30% more heat. So when we identify, and we came across this issue early on in the U.S. In the U.S., we have what's referred to as a Y three-phase configuration, which is where all three legs are 208 volts, equal. And then we have a delta configuration where two of the legs are like, 120 volts and one of the legs is like 180 volts. And we were having some scorching issues and things like that happen with high leg delta systems. With European power, I believe you guys are always on harmonized power, so each leg should always be consistent. But it's something to check because and we've even considered doing this, and we might be able to remedy for you relatively easy just by reducing the wattage of your element. So if anybody is having just reoccurring issues with their mash tun element more specifically, even despite running a sufficient amount of wort through, you're getting good flow, and you really can't quite explain it. Let's sort of go back to the basics and take a look at what the house voltage is, and see if that's consistent among all three legs, and see if we can identify any problems related to that. Because that's sort of a first place to look. So since again, with the 2V system, we can regulate the voltage. So, we can come out with basically a change to the software. We reduce the amount of voltage that's able to pass through the voltage regulators, and that in turn reduces the wattage of the elements. With the 3-vessel system, we don't have that ability. So, looking at the house voltage is going to be where we should start to diagnose any potential reoccurring scorching issues.
So let me give you a little bit of background about at least the Dutch electricity network, Michael, because you're gonna hate us for this. In Europe we use the rotating 3-phase. So we have you have your zero. It's called the zero. You've got the 3 phases. Each phase is 230 volts. Yeah. And each phase is allowed to be 10% over or under. Yeah. The problem is that when you're using like 380 volts, every country has their own different word for it. Like in the Netherlands, we call it krachtstoom, power energy. I don't know why we call it that way, but that's actually allowed to have a 10% off as well, because the phases can be off. The Dutch electricity network is kind of on its last legs. So on a very sunny day, we've disproportionately subsidized solar. So on a sunny day, we will see voltages up to 250 volts per phase.
Yeah. In areas. Wow. Okay.
Yeah.
Yeah. That'll do it right there. That could be the cause right there. I mean, 250 volts per leg is extremely high, and that's likely what's causing some of the issues there. So I think let's take a look at that and investigate it a little further, and it is something we can remedy. I mean, you got to think with these elements, all we have to change is the resistive wire within the tubes, and we can lower that. It might not give you the same performance when voltage is on a more regular, level, but at the same time, if you just want the consistency and you're not as concerned with step mashing or raising the temperature of the mash tun very drastically for mash outs, things like that, you just want to get through a brew, have the temperature be consistent and no scorching. We can definitely remedy that situation.
So since we're recording today and we have some, so I know that we have quite a few people that are asking about this. So I think that if you burn your first element, we've all done that, right? I've burned quite a few elements, I'll tell you that. But I think once you're in your 20th element, there might be something more going on.
Yes, exactly.
What would you say is the best strategy for those people to move forward? So reach out to Brouwland, of course, but is there install a voltage meter so they know what the voltage is running through the system as well?
Yes. And some people, if you have the, like in the US, we can get step down transformers relatively easy as well. So if it's something that easily can be installed along with your main switchgear, you might want to consider a step down transformer in the immediate time frame. With elements, with just our, production and all of that, the time frame isn't just a quick turnaround to get new elements batched out. It's usually about 3 to 4 months minimum. So, sort of in the meantime, yeah, if you are consistently burning out elements, I would look into, a step down transformer. And then also, I would say reach out to our support desk directly. Or Mendel and I, we converse via email quite frequently. He can sort of, catalog the names. That way we sort of know what the demand is. And we can do a short run batch of elements and get that done in just the correct quantities and all that. We don't want to leave anybody out. So yeah, let's go that way. Let's just, funnel everybody into Mendel for the time being, and then, we'll come up with a list and go from there.
Yeah, we need to investigate it for sure, and then the voltage, and then we can search for a solution.
Yeah, exactly. Mm-hmm.
Mm-hmm.
Does this make this happy, Stijn?
Yeah, let's hope so. I never measured the fluctuation on the voltage, so I could not say it, but it sounds like a possible solution. I have often brew days where I do 2 batch at the same day, and the second batch is then completely burnt, and I do exactly the same as the first batch. I took out the element after the first batch, inspected, not burned.
Yeah.
Mashing the second batch, and completely not a small bit, but literally 360 degrees all over burnt.
Is your second mash, when you're using the element, would that be around 1 to 2 o'clock?
Normally, yes.
Yeah. That could be the fluctuation in mains power. You have to look at these elements, especially on a 3-vessel system. I mean, it's basically just like a large resistor, a light bulb, if you will. So, feed it more energy, it's going to burn brighter. And if what Cornel is saying, it's like where you get mains voltage changes throughout the day with the use of solar energy. Things like that. That could be the cause, definitely. Because there's no in a 3-vessel, there's no way for the brew house to manipulate or change the power dynamic in any way. There's a contactor. It opens up that electrical connection directly from the grid to the element. The element is going to be a direct representation of how much voltage and amperage that it's being fed. That's how wattage is calculated. It's just voltage times amperage. A little more complicated on a 3-phase system, but for the most part, that's what it is. And so I think this will probably solve the issues. I think like I was saying, it's like if you find yourself brewing during that time of the day, using a step down transformer that you can basically activate, turn on and bypass the power through there. That would help you, immediately right now, which is current elements. But of course, we're open if this is a more, widespread problem we're seeing. We're open to doing a short run on just lowering the wattage of the elements, and we just run some calculations, based on some of the voltages that some of you are seeing, and probably come up with like a 3200 watt or 3500 watt, something along those lines element that is going to be much more of an all around better wattage for your dynamic power.
Yeah, sounds like a plan.
Yeah, that's indeed. And also, like Michael said before, Stan was in, keep it clean. That's also very important to have like an acid rinse to keep the surface of the heating element smooth and clean every time. Because when there's a little bit calcium or something, it can
So
it can
regarding that,
keep on getting
so
dirty.
yeah, so let me. I need to Google the English name for this. Perazijnzuur. I don't know what it's called in English. That's the problem. So peracetic acid. Would that be the right acid to use? For this?
Peracetic acid.
Okay.
Even like any strong nitric acid. I know that's very not as commonly used in breweries any longer with environmental regulations, but peracetic acid works fine. Anything that you would clean some of the calcium buildup off your kegs or your fermenters, that same acid that you're using. But I want to stress that for these systems, PBW and SaniClean or more of the homebrew chemicals, it's not going to get it done. It's just and I'm not insinuating that you're using that or anyone else. I'm just putting it out there that it's just not going to be strong enough to clean these elements without removing them and scrubbing them every single brew. So if you're using industrial grade cleaning chemicals, just like every other brewery, it's completely fine. But yeah, peracetic acid is a perfect option.
Yeah, so not nitric acid, right?
Yeah, nitric acid is fine. Like even if you have a passivation agent or something along those lines, any of those acids sort of work the same
Phosphoric
way.
acids.
So, yeah, exactly, same thing. All of them work.
Yeah, because in most breweries you would see nitric acid as a passivation agent.
Yep.
Run once every year.
Exactly.
And the other acid, we call it in Dutch is perazijnzuur, and when we use that like to disinfect everything. That's the usual thing. You run through everything. So
Exactly.
to be honest, I never ran that through the brewery. So I'll start doing it too.
Like give it a try because that element should really look like the day it was new. Every brew, it should be shiny. There should be no powdery buildup.
The thing is on the 3.5 system, you see the elements, so you can visually see if they are smooth and clean.
Yeah, see, like that looks like the day it was new. So again, it's good care.
12 points.
Yeah, exactly. Well done.
There you go. So, it's all I wanted, just a compliment. It's all I
wanted. Well done. Yeah.
So one of the questions that Mikael had about the temperature. So I'm now running 150 liters. You are saying so I'm keep having overshoots on my 3.5 barrel. So right now I set it to a wort temperature of 40 degrees, and my wort temperature is between 40 and 42 degrees approximately. So there is some overshoot, but it's a couple of degrees, and I would be able to live with that. I would think it's mostly because of the elements just giving it their best while we're recirculating.
Yes. Usually that would come as just a concentration of heat at the bottom, and not being able to homogenize or disperse that heat in a short period of time. And it all has to do with environmental conditions as well. If your brewery temperature is on the cold side, obviously it's an uninsulated kettle. So it's going to be more fluctuation based on exterior temperatures as well. But you can always set your temperature a degree or two lower, knowing that the environmental conditions. If you're getting 1 or 2 degrees of overshoot on your mash, just set it 1 degree lower and job done.
I will show you a special guest because he just drove up because he's finally bringing back some of my crates. This is it's Bart. He is from a brewery at Sonnenbreugel, Engelbertus. And he's actually running my old 1 barrel system.
Oh, awesome!
But, and he's just bringing back the crates in which I store some beer after 6 months of borrowing them. But He also came back for a special, very special piece of the brewery.
Oh, the Calandria, yeah,
He
the
forgot this
Calandria
one.
wing nut. Yeah, the wing nut.
You can wave. So here's Bart. So
Hello, good to
Hi,
see
Bart.
you.
ze staan je ook een beetje, ja. So this is, I'll point at people. So this is Mendel, you know Mendel. This is Stijn from Brewskebar. You don't know, this is Michael, this is the president of SS Brewtech. So he built the brewery that you're using.
Awesome,
Very
awesome.
good.
Glad to hear it. Hope you're enjoying the system. Thank you.
Have you made good beer on the system? Not good beer?
No, we haven't brewed yet.
You
I
still
don't
need
have
to.
brewed. I'm like, oh God, the beer's bad. It's awful. Yeah, yeah.
All right, I'm still here. Dankjewel, Bart. Waar is al mijn bier? Waar is al mijn bier? Sorry, he just dropped in. He's only done play brewing on it yet.
Okay. Okay.
They've mostly purchased it because it just looks so cool in their in their tasting room, and as soon as they get the permit from the government, they will start brewing as well.
Yeah,
so they're very good.
Good to hear.
Anyway, so do we have more questions for Michael? Now he's here, and we can bother him all we want.
Mm-hmm. Yeah, now's the time.
Shoot.
Not for me. I hope I'm gonna get an electrical guy in, and he's gonna measure some stuff during the brew day, and I hope that's the solution.
I'll get you, Stijn. So I'll send you a text, and I'll send you a little meter that you can easily wire in. You can do that yourself. It's super easy, and it will actually show you voltage during a brew day.
That's good.
So
we will also keep in touch because I also want to know the outcome of the test.
So let's get back to because now I remember the overshoot thing. So one of the things that Michael mentioned is that when he's recirculating in his 3.5 barrel, he gets, even with just water, he gets quite a bit of overshoot. So I've set it to 40 degrees. It's 150 liters of water, which is about, I think, 30 gallons, 35 gallons. Set it to 40 degrees, right? Right now it's stable at between 40 and 42 degrees. Would you say that's normal? Is that something we can expect, or how close should it be?
Yeah, if like I said, like all of that, and this goes back to just the fundamental issue of controlling temperature within a mash, even if it's just water, is you have that false bottom barrier between the elements and the actual the medium that you're trying to heat and maintain temperature. So we've done a lot of programming on the screens and in our firmware to try to be predictive about how the temperature is going to homogenize, how it's going to rise, and how we should think about maintaining temperatures once temperature has been reached. But with that volume of liquid in an uninsulated vessel, having a 1 to 2 degree swing is about as close as we can get. Without knowing the environmental conditions of everybody's brewing space. Some people brew when it's super cold, and the element in the vessel just has to work a little harder to keep temperatures consistent. Some people brew when it's room temperature, or some breweries can get very hot, especially during the summer, and you might see less overshoot, for instance, because the elements, even though they have a voltage regulator on them, they're we use a PID algorithm with some adjustments to it. So as soon as the temperature gets too far away from the desired set point, that voltage that is being fed to the element raises exponentially. So to try to overcome that temperature change. So on an overshoot, especially if it's something that for your initial mash in, and you've recorded this happening over and over again for your brewing space, once you sort of get to temperature, just walk away from the vessel for 5 minutes or so, and it'll likely homogenize and return back to the desired set temperature, because it's coming off that that big heat up or warm up period where the element was running at basically 100% trying to get to temperature.
Fair enough. So do we have any other questions we want to ask Michael? Well, because I also want to be respectful of everybody's time. You've already given us a great wealth of information and things to look at. Oh, you need to unmute.
Oh, mute.
Yeah,
There we
I
go.
would like to say, are you planning some kind of like accessories for? Because what I was thinking actually, what could be nice to, if you steer during meshing, then step meshing would make things much easier.
Yeah. Yeah. Certainly, we when we designed the original 3.5, we wanted to get a rake motor on there so bad, but it was always a balance between keeping pricing very attainable, especially for a startup brewery, and then looking at the feature set and saying what can we do without. And unfortunately, we did make the decision to not put a rake motor on the mash tun for stirring during mash and step mashing and things like that. I know people that have done it. It can be done. It's interesting. I'd be curious if anybody on this call is also interested in it. If you shoot Mendel, I know you, Courtney, we've talked about it before, but shoot Mendel a note. I'd certainly love to take sort of a little bit of an informal poll on accessories that you'd like to see made for the 3.5. I mean, certainly we can do it. It just takes enough people to want it, and we can make it happen. So yeah.
So
Okay, take your word.
So for my 2 cents, I wouldn't want the mash rates. They wouldn't make, so for me personally, they wouldn't make too much sense for me, because to be honest, the filtration works really well.
Mhm.
I would love to have a good, either a propeller or a good circulation system, because every time I've had issues with circulation for the step mashing and like the mash out, anytime circulation has been an issue, it was because I was brewing on my own and I was doing a heavy brew, and I did add 400 liters of water, but then I also added 200 kilos of malts. And I know that's hitting the limit, but at a certain point, just manual stirring, it just doesn't get it done anymore.
Yeah, it won't work. Yeah. Mhm.
And that's
People from
right.
the Netherlands,
We just want to brew
They-
heavy beer. That's what it
they
is.
are not that strong. You need Belgian people. for
Yeah.
that.
The
You were
last time
saying 200. Sorry, you were saying 200 kilos of malt.
So we can't tell Michael, but I actually did a beer that had 240 kilos of malts.
Say again.
240 kilos. Yeah.
It can fit.
It can fit. Yeah.
Okay.
Yeah.
You will not have a fun day, and I'm pretty sure it is outside of warranty. But yes, I made a full grain triple. I did add some candy sugar to it, but without the candy sugar, I was already at like a 9.3% full malt, and it just worked. I did have to use the rescue underlet, I'll tell you that, and it was very hard to do. And I don't think I'll ever do it again. But yeah, 240 kilos. It was also a bit of a combination, like, oh, it's lying around, let's just throw it in. But it definitely can be done. But I know that for my brew day, so we regularly do have brew days here with 175 to 200 kilos. If there's a stirrer, just a motor in there, a propeller that helps with stirring in the beginning, especially if you're alone,
Yeah.
That would make your brew days a lot easier, because if the initial stirring goes well and you have a very well mixed mash, the chances of you getting a stuck mash are greatly reduced.
Yeah. Yeah. Agree. Mm-hmm.
It's so I've been looking into getting one installed as well, but it's like I have this list of stuff to do, and it's here. That's my.
And you know, we've messed around with the design of a mash stirrer for it. What would likely happen is a full replacement lid, and we would convert the lid from a, you know, sort of this kind of half moon open to a manway, more of a traditional manway, and then, you know, add a rake motor would attach on top and have a, you know, stirrer drop in from above. And it would basically permanently affix itself to the kettle. So you wouldn't get the same ability to stir the mash manually any longer, because you'd be just working through a manway. But you know, certainly you'd have a rake motor there to, you know, to do it for you.
Yeah. So one of the things that if that's an option, you can write me down, and I don't even really mind the cost at that point, because one of the things. So if you, I'll show you a little bit. As you can see, I spent some time on making this look pretty, right? So that's my bottle filler, and we made it all look very pretty. The thing I absolutely hate every time, is when we put in the molds, because everything gets dusty. Everything is dusty. Because of the open design, it just, everything is dirty again immediately. And with the manway, you can close it off a lot easier and get it a lot cleaner.
Yeah, and we would probably include a port for a hydrator with the grain auger setup, so that you could mash in remotely through an auger and a hydrator.
Great, so ship tomorrow.
Okay, we'll do it. No, things take us a little while. We have all these home products constantly getting in the way, so you know But no, I would encourage anybody, if they have you know, some ideas on, you know, accessories that they would like to see, you know, reach out to Mendel directly. We'll kind of put a spreadsheet together, and
just send me an email.
It's sort of the way we've always done it in the past. You know, if there's a demand for a product, we'll make it. You know, if there's not as strong a demand, we won't make it. You know, it's sort of simple as that. So.
Fair enough. Any others?
Maybe I have issues with steam condenser. It doesn't seem like working properly, or I don't know. Maybe the pressure in the water system is too low, or it you know, it makes foam all the time.
Okay. Have you removed your elbow? You know, the elbow at the top. Have you removed it and taken a look at how the sprayers are spraying? Are they? I
think it points down.
Yeah, but like, you know, you know, it should be sort of like a mist. It should be well atomized. And you know the reason we shoot them down is because we're trying to draw the steam out of the kettle itself. So we're trying to create basically a vacuum by shooting the, you know, kind of atomized water down. But it should be a good spray. If you're just getting like kind of any dripping through there, or not a good fan of water that's being, you know, projected through that pipe, you know, then definitely it could be problematic. But yes, you know, go ahead and remove the elbow, turn the sprayers on full blast. Yeah, Jesus, what's, you know.
So this is what you get when you.
Are you doing boilovers in there? Yeah,
Sure.
You got boilovers happening in there?
No, so this is what you get when you rent out a brewery and tell people you should clean everything, and then they tell you, yes, we cleaned it.
Yeah. So again, if that's ever happened and you get a boil over and all of that, you know, hot material, you know, all of that, you know, gets forced through the elbow there and into the steam condensate stack, it will, you know, obviously kind of leave all that stuff caked on the inside. It'll mess up the spray pattern. and not be as effective as it could be. So not saying that that's what's going on, but also the other thing too is if you're using the stack a lot, same thing, like think of it like a shower nozzle. You'll get some calcium buildup or something like that on the sprayer, and the sprayer just needs to be removed and soaked in an acid solution, and then you're good to go.
So I don't know how well you can see this.
Yep. Yeah.
This is what it should do, right? Like a
Yes.
vaporized spray.
Exactly. It should be a nice fan, laminar fan.
I hope you guys can see. I'm trying to not aim at the laptop, right?
I checked that at the beginning. It was
Yeah, we can see it.
like that. I can check it again, but
So as so I actually run a pressure razor, a hydrophore. So I have a 1 cubic meter container that's in the technical room, and I always have a constant 4 bar pressure in the brewery, and that helps a lot with like these kinds of things, but also the plate chiller to have a constant 4 bar, because everything runs a lot more smoother and consistent than plugging it in directly to the water mains.
Mm-hmm.
That's one of the advices I would give you.
Yeah, it like to Cornel's point, if your pressure is too low and you're not getting good fanning and good atomization happening there, that could be a cause as well. And yeah, I would encourage you, pop the elbow out, or one of the sprayers, have a go at it, and sort of see what happens with your normal brewery pressure. Before you go ahead and invest in anything to change up the pressure. It could just be any one of those things we just discussed.
okay, I'll do that. Thank you very much.
So
No
when
problem.
you're doing a boil, what's the percentage your controller is at?
Percentage. It depends on the amount. Something between like 65 to 75 with the lid closed.
Yeah, that sounds about right.
Yeah.
So my brews are usually between 65 and 70. So as soon as we see it getting to a boil over, we dial it down to 65, 70, make sure the condenser is on. Oh, and make sure you run the condenser with cold water.
Mm-hmm. Yes, that's important. Has to be cold.
I made the mistake of running it with warm water. Then it doesn't work.
Yeah, it won't work.
Mm-hmm.
There we go. Condenser questions. Any others? I think we went through most of it.
Yeah, I think we also went through most of it. We had a few other questions from some customers that are not in the session, I guess. One question was about the temperature probe that's on the checked unit tanks. And the question was that he couldn't connect it to the FTSS touch. But the answer is that it's a PT100, and you can connect it to the FTSS Touch Pro if you buy it.
Yes. It's the home FTSS is a little bit different. So the FTSS exactly. So if you're using the home FTSS kit, you have to use the probe that's included with that kit, and just use the thermo well. And we always sort of recommend using some thermal grease or something along those lines to pack that thermo well so you get good heat transfer. But for the FTSS Pro, it's designed to use with standard brewery grade PT100. Yeah.
Or if you have another system, you can also use a PT100, of course.
Exactly.
And then another question was about profiles in Beersmith or Brewfather. Cornel has some good profiles for the 3.5 and 1 BBL system. So we will share them with all the customers so they can use it in Brewfather.
I think
And
it'd be
then-
good anyway when to send out a summary email around some of the tips we got, like the acid wash, things like that, to make sure that. And we can also get some people send in, like, what are they missing on the brew house? What is it that you want? What is it that you want to invest money in to make sure that, like the stir for the mash tun and things like that, to get a more complete list.
Mhm.
Yeah, indeed. You can always contact me, and after this session, Cornel and I will also sit together to make an email to send to everybody with all the information and the recorded session. And there was another question about some step-by-step videos for the 3.5 and 1BBL system. Cornel and I already made a video, but we're still editing the video at Brouwland, and as soon as it's ready, we will share it. So there will be a step-by-step video for the 3.5 system. And yeah, the new 1BBL system is almost the same. So yeah.
And they're applicable to the 1BBL as well. It's just the brew steps. There's some different controls, but the steps are the same.
Yeah, indeed. So I don't know if someone else got any questions about the brew houses or the tanks or accessories.
Not, it's an early day, time for beer. Well, not for you, Michael. You need to work.
Not for me. I'm still going on coffee. So exactly. No, I appreciate everybody taking the time, and I'm certainly open to doing more of these. I'm all about the community interaction and getting more feedback so that we can continue to develop better products or improvements to our products. And of course, solving any issues out there that is just lingering for people, like, potentially this voltage issue and things like that. We don't want to have a brew house there operating like that, where, you're going through elements like crazy. That's just not right. So we want to get that sorted out, as soon as we possibly can. So
I'm very jealous right now.
Yeah. Yeah, I think it's good if we have another session in let me say a few months or something.
That'd be great.
If there are more questions, then we do more sessions, so that everybody understands the systems, and if they have any questions, they can be solved. Yeah.
Perfect.
So I don't know if anybody has any questions. If there are no questions, I think we can close the session and grab another beer.
Sounds good.
Are there more new products coming?
Yeah,
Yes.
yes, always. We really feel like we've got a good mix. We're not going to be changing the platform of the 1 and 3.5 now that they're sort of sister systems. We really love the platform, so that design will remain consistent. But I believe that we'll continue to introduce accessories to support those size brew houses. One such thing we're looking at is a keg washer, which I think would be a really cool product, and have it be priced in such a way that is really attainable for everybody. When I think of keg washers now, it's this huge investment. They don't work all that great. So having something that that's more simplified, easier to operate, is something we've been thinking about for a little while. Cornel tells me that there's big demand for a CIP cart. We'd be open to something like that. I'm curious on the demand. So again, send Mendel an email if you'd be interested in seeing something like that. But those are products that we can get to relatively easy, just because we've made them in the past for our larger systems, and we can do a scaled down version and things like that. But if we know that there's a demand, we'll make it happen. So
I'll give you one simple reason why I want a SIP card. The reason stands right there. It's that stupid Italian pump that costs $1,200. And I think I can make a SIP card for that money, but that's.
Yeah. Yeah, we're also working on a, I don't know if this has been thrown out there. We're also working on some in-house design pumps right now. The homebrew pump is coming first, but then we're going to be doing a nano size pump. And that would be a perfect segue for both a keg washer and a CIP cart. Once that nano size pump is through its development and testing phases, we can implement and use that pump more widespread. Also, for those with a 3-vessel, 1-barrel, and a 2-vessel, for that matter, we're going to make the nano pump sort of backwards compatible with those systems to replace the current pump that we feel just isn't up to the performance and sort of the quality we would like to see. So that we're able to just go ahead and do a drop-in replacement for those systems that are again continue to have issues with whatever noise that the current pump makes and things like that. So we're aware of the issue and working on the fix. So.
Yeah, and if you guys have any recommendations in the future, you can send me an email and I will talk about it with Michael. No problem.
Perfect.
Okay, I hope you guys enjoyed the session. Like I said, give us some time and we will send everybody an email with all the information, pictures, proof order profiles, and then we can meet again in a few months for another session if necessary. I don't know if Corneel or Michael has something else to say.
No, I just want to say thank you to everybody again, and look forward to speaking in a few months if we can put it together. Sounds great, and enjoy your beers. I wish I was there to partake. So yeah, cheers.
Thank you, everybody.
Cheers. Thank you.
Cheers.
Thank you for your time, Michael.
Thank you
Thank
very
you.
much.
Thank you, everyone.
Bye. Cheers.